Alrighty, we are back with Unit 6, Part 5. So, by now you've taken the summative, you know all the basics of the y equals mx equation. We're going to add one more element to it this time around and get the final product, what we're going to be looking at for the rest of this chapter. We're going to do y equals mx plus b. So that b incorporates the y-intercept, which is the only other part of this whole function thing you have to know right now. It's not that bad, and these steps are going to walk you through it. So we're going to start with our review section like always. I want you to go ahead and try plotting the line y equals 2x, and then tell me where it crosses the y-axis, and try to plot a line that doesn't cross the y-axis at 0. So try these. I want to make sure you can do this before you move on to the rest of the notes. So pause and give it a shot. Awesome. So let's go ahead and plot y equals 2x. So our first point is going to be at 0, 0. We plug in 0, get out 0. Our next is going to be 1, 2. We'll have 2, 4. And for fun, we'll also do like -3, -6. Now we're going to go ahead and plot these points. 0, 0, 1, 2, 2, 4, and -3, -6. If you don't know where I got these points from, you should go ahead and go back to our older videos to make sure you know how to plot a y equals mx equation. Then we're going to connect these as a line. And this line here is y equals 2x. Now, where does it cross the y-axis? The y-axis is this line right here, so it's going to cross at 0. If we're asking about a specific point, we'll call that point 0, 0, like so. Now I have a challenge to plot a line that doesn't cross y at 0. So this isn't actually too bad of a challenge. I'm going to go ahead and just come up with a random line. Let's do something like this. And the most important thing is I just want to make sure while I'm creating this line that it doesn't cross right here at 0. So that one is way lower than 0. It's not going to cross 0 at all. So we'll come back to that in a second. First, we want to ask ourselves, what does the word intercept mean? Well, it means where things collide. Come into contact. Or even just where things cross. So intercepting is colliding, contacting, crossing, all of those things. That's relevant to what we see here. So a y-intercept is where a line crosses the y-axis. And that's what we see here. That's why I asked at the top, where does this line cross y? And we had a different y-intercept because we didn't want to cross at 0. So a y-intercept is just a point. It's where the line crosses the y-axis. Since this point is on the y-axis, the x value for the y-intercept is always going to be 0. No matter what it is, your x value is always going to be 0. That means the coordinates, the point for the y-intercept is going to look something like 0, comma, y value. Whatever your y value is going to go with 0. That means for our 2x line, y equals 2x, our y-intercept was 0, 0. Now, what is the y-intercept for the line you plotted? You're going to look up here at your picture at the top, figure out where your line crossed the y-axis, and make it a point down here. Mine was 0, -3. Yours may be different. And it's 0, -3 because that's the point where the line crosses. Okay, so all of the lines you've plotted up until now, up until these notes, have had a y-intercept of 0, 0. think of these y-intercepts as moving. Think of these new y-intercepts as moving those more basic lines up and down from their starting location. So think of this left line as its starting location. And if we compare it to the one on the right has moved up a little bit. So we can think about the line on the left moving up and moving up to its new location. So this line has literally gone from here and moved all the way up to there based on its y-intercept. We're going to compare these two. Same thing on the right. This line here, with its y-intercept at 0, has moved down so that now its y-intercept is at -3. It's moved down from here to there. And that's really what a y-intercept does. It's moving a line up or down from its starting location. So that's it. That's all a y-intercept is. It's the point where a line crosses the y-axis. We're going to be using this y-intercept here in a minute, but I want to make sure you can identify them for the lines above. So for all 4 of these, your checking understanding is to list the y-intercept as a point, like we did here, here, and here. Give it a shot, and when you're done, we can flip to the back. All right. So now that we've done all that, we can add an extra element to our y equals mx equation. It's not going to be enough to represent our y-intercept now. We're going to have to introduce another variable, the b. We have y equals mx plus b. So in this case, our slope is still m. Our intercept is going to be b. And we still have our input and our output. So, our b answers an important question. What happens when we start with something other than 0? And now, what I really mean by that is for every situation I put us in where functions matter, we've always assumed we're starting at 0. 0 money in your bank account, 0 money on the first week, 0 steps when we've started. That doesn't actually represent a lot of realistic cases. We always have something to start out with. You always have some basic money. You always have some points. You always have things that you're starting a new function with. Your y-intercept is where you're going to start on a line. So it's going to be your starting point. It's going to be up or down from 0. So here's how that b works. When we plug in 0, our starting x, the 0 times slope cancels out. That means b is all by itself. Now let's see it in action. Let's look at a random line. Let's say y equals 2x plus 1. So when we plug in 0, we end up doing 0 times 2. That cancels out. And we end up having a 1 left over. When we plug in 2, we end up doing 2 times 2 is 4. 4 plus 1 is 5. When we end up plugging in, let's say 3, we do 3 times 2 is 6. 6 plus 1 is 7. So we're still doing the input and output like before. We're multiplying by 2, but then we're also adding 1 at the end. Let's do a negative 1. So if I put in negative 1, negative 1 times 2 is negative 2. But when I add 1, it's going to cancel out a little bit. We end up with a negative 1 here. Try that in your calculator. You'll see that when we plugged in negative 1 times 2, we had negative 2 plus 1 is negative 1. Now if we plot that, we'll end up with a 0, 1, a 2, 5, and a 3, 7, which is actually a little bit above our grid. We also had a negative 1, negative 1. Like so. I can connect these points. And this is going to be our y equals 2x plus 1 line. Notice how it is very clearly above the y-axis, the origin here in the middle. We can compare that to y equals 2x, where we have 0, 0. Plug in 1, get out 2. Plug in 2, get out 4. Let's say plug in -1, we get out -2, and so on. When we compare these points, we have 0, 0, 1, 2, 2, 4. You'll see that our y equals 2x line is slightly lower. Because this +1 has moved it up. The +1 intercept moved it up. So the rest of the line ends up looking really similar. Everything is just moved up or down a bunch. Really, all this means is that the B tells us how far up or down we draw our line. That's really all it does, is it tells us how far up or down we draw our line. Okay, so that established, let's switch gears a little bit. We don't have to go through so much effort to plot lines. We can incorporate the y-intercept without too much trouble with just doing our rise over run kind of thing. So let's start with rise over run again. I want to reiterate the steps and show you how to do it. Then we're going to go ahead and actually write out our entire y equals mx plus b equation. So our 4 steps are plot 2 points, count up for a positive slope, or down for a negative slope. Then we want to count right, and then make a fraction. So for this line here, I'm going to plot 2 points. I'm going to have a point here and a point here. I'm going to count up for 1. I'm going to count over for 2. So our slope is 1/2. Our y-intercept is going to be 0, -2. Now, looking back at the top, our equation was y equals mx plus b. M is our slope, b is our intercept. So, if we want to write our own y equals mx plus b equation, we just take our slope and our intercept. So our m is slope, we do 1/2, we just put x. And then our y-intercept is -2. That's our y value. So we're going to go ahead and put -2. That means our y equals mx plus b equation is just y equals 1/2 x minus 2. So we can also go the other way. Given a y-intercept and a point, we can draw a line and figure out the slope. So we're going to draw the line with a point at 3, 2, and intercepts the y-axis at 0, -1. I've got one point here, and another point right here at 3, 2. I'm going to connect these with a line. Then I can find the slope by doing rise over run. I go 1, 2, 3, 3 up, 1, 2, 3, 3 over. Slope is going to be 3 over 3, or 1. So we have our slope, and we also have our y-intercept right here. Based on that, we can actually go ahead and do our checking understanding as well. What is the equation of the line you drew above? That's where I'm going to leave you today. Go ahead and try creating a y equals mx plus b equation from this slope and that y-intercept. If you can do that, you've got everything you need from these notes. So give it a shot. And as always, if you have any questions, let me know. Thanks so much.